A very good morning to all the students. In today's session, we are going to discuss about a topic on the repetitive statements. In the previous discussions, we have discussed that there exists two types of statements from which we can break the sequential execution of the C program. One type is based upon the conditions, and the second type is when we want to repeat some set of statements, a single statement or a block of statements, then those type of repetitive statements we call them as the looping conditions. So this looping is the other name for the repetitive statements, and there is another technical term for these repetitive statements which is called as the iterative statements. Iterations or repetitions or looping, anything, they refer to a situation where the user has to repeat a statement or some set of statements for n number of times. The statements that depends upon the condition, like if else, nested if else, switch case, all these things we have seen in the previous videos. And today's topic of interest is about the repetitive statements, right? Let us see why we require these repetitions, why we require these repetitive statements or loops. So sometimes the programmer may encounter a situation where he or she has to execute a set of statements for more number of times. In such situation, these looping constructs that are available in C is very much useful, and by using these looping constructs you can repeat a set of statements for n number of times, any number of times you can repeat. So that is the purpose why we are going for these looping constructs in C. Right. Now let us see what are the various looping constructs that are supported in C programming language. Or we can simply say that various loops that are supported in C programming language. The first and foremost thing which we can discuss under this loops concept is the for loop, and the second one is the while loop, and the third one is the do while loop. So as we know that a loop statement allows us to execute a statement or a group of statements multiple number of times, and various looping constructs that help us to do so are the for loop, while loop, and do while loop. We will discuss the syntax and how it is going to execute. All these things we will discuss, but for this point of time you just remember that these are the three constructs that are available in C for repetitions, and out of these three things, the for loop and while loop, they are categorized as entry control loops. And the last category is the do while, which is called as the exit, or which is categorized as the exit controlled loops. What is this entry control loop and what is this exit control loop means? The entry control loop means whether we want to repeat the set of statements or whether we want to exit from the loop, it entirely depends on a condition. Again, all these three constructs, they depend upon a condition. If the condition is true, they will execute the body, and if the condition is false, they will skip the body. So whenever the condition is checked at the entry point, that means before entering into the loop, if the condition is checked, then we call such type of looping constructs as the entry controlled looping constructs. So for for and while loops, we are going to check the condition before entering into the loops. Hence, these two are categorized under the entry control loops. But whereas if you consider this do while, we are going to check the condition while we are coming out of the do while, or while we are coming out of the construct. So that is the reason why it is called as the exit control loops. So we will see one by one with the syntaxes and how they are going to execute with the syntaxes, right. Let us start our discussion with the for loop. The syntax for the for loop is, it starts with the keyword for, and after that we'll put a parenthesis, a set of parentheses, and within the parenthesis we'll have three different components, and the first component is called as the initialization component, and after the first component you have to write a semicolon, and the second component is the condition component, and the third component is update component. And once we close this parenthesis, we open the curly brace, and within the body of the for loop you can write any number of statements. Let us take this as statement 1, statement 2 and statement 3, and out of this for loop let us write one more statement, statement 4. This is just a generalized syntax. So once again I am repeating that the for loop consists of three different parts or the components. Perhaps these three components are common for any looping construct that is available in C, but the position where we put this initialization, where we put this condition, and where we put this update, they differ from one construct to another construct, right. So this initialization we will see it in while loop and do while also, and the condition we will see it in the while as well as in the do while, and similarly the update section also we will see in the while as well as in the do while section. So all these three components are essential for any looping construct, but the place where we put this initialization, condition and update depends upon the looping construct you are going to use. This is the syntax. So let us check out how it is going to execute, right. As I told that the syntax always starts with a keyword for, and the first part is the initialization part. So whenever the compiler comes across the first statement, it is going to execute the first part as the initialization part. Once the initialization component is executed, then the second part it is going to execute, the compiler is going to execute, is the condition. And we know that the condition can be any statement, that means it can be a relational statement or it can be a logical statement or anything else, but the ultimate goal of this condition is it gives only two outputs, true or false. So based upon the condition output, if it is true, then it is going to execute the body. We know that the body of any construct starts with the curly brace and ends with the closing curly brace. So this is called the body of the for loop. So once the condition is evaluated, if the condition is true, then it will execute the body of the for loop. So the third part which is going to be executed is the body of the for loop. Once the body of the for loop is executed, the next part which it is going to execute is the update part, that is this one. So you may have a doubt that what is this update? Update means it can be an increment or it can be a decrement. What we are going to increment and what we are going to decrement means the entire looping constructs, whether it can be a for loop or while loop or do while loop, they depend upon a particular variable called counter variable. So this counter variable, we keep track of how many times the loop has to execute, when the loop has to stop its execution. All these things, they depend upon a variable called the counter variable. It is just a normal integer variable where we will start the counter value with 0 and we can repeat some n number of times. But who is going to check how many iterations it has completed? One iteration means nothing but one loop or one time execution, we call it as one iteration. So how many times the loop has iterated, who will make a count of it means it is being noted by this particular variable which is called as the counter variable. So from 0 to n, all these n times, it will, the counter variable will keep track of it, right? And the update section is nothing but the increment or the decrement part of this counter variable. So initially we will initialize it with some value like example 0, and then you increment it, therefore the counter variable value becomes 1. When you update it, it becomes 2. When you update it, it becomes 3. Like that, if you want to check the counter variable up to 5 times, or if you want to iterate the loop for 5 times. So you keep on incrementing the variable or the counter variable until it reaches a value of 5. That is the part of the increment and decrement. So this increment and decrement is related to the counter variable. And once the increment is done, again it will go and check the condition. So from here it is going to execute this one, and from here it is going to execute this part, and from here it is going to execute this part. Again after update, it is going to execute the condition part. Again it will check for the condition. If the condition is true, then it will again execute the body of the for loop, again go for update, again check for condition. If it is true, execute the body of the for loop, update to check the condition, execute the body, update, and this particular scenario continues until the condition becomes false. Until unless the condition is true, the body is going to be executed and update is going to take place, and every time the condition is going to be checked. And when we are going to stop this looping, or when we want to stop this iteration, means it depends upon the condition which you are specifying. Very important thing in any looping construct. So specifying the condition is to make the number of iterations limited to a finite value. So you should be very careful in specifying the conditions. If you are not taking care of how to specify this condition, there may be situations where any looping construct may enter into a situation which is called as infinity loop. Infinity loop in the sense the repetition of statements will continue for infinite number of times, which is not at all a required situation. We should avoid these infinite loops. In order to avoid these infinite loops, be careful that the condition should be specified in a correct manner, right? If you don't specify this condition, be careful that it will enter into the infinite loops, which is very dangerous situation, right? So this particular condition, body of the loop, update, condition, body of the loop, and update, they keep on repeating like this. They keep on repeating, and this one happens, this repetition happens until the condition becomes false. At this point, let me tell you one important point, that how many times the initialization has been executed in the for loop. You can observe while in the explanation that the initialization is done in as the first part only. You have done it initially. So the initialization is executed only once. This is very important point. The initialization component in the for loop is executed only once. And what happens to this condition? The condition is executed n number of times. Actually, this depends how many times the condition has to execute, whether it is going to execute for 5 times, 10 times, 100 times. It depends entirely on the condition, right? Until unless the condition becomes false, it will continue its execution. So n number of times it is going to execute. At the same time, the body of the for loop also executes for n times or n minus 1 times. So it entirely depends on again this condition. Similarly, the update section is also going to execute for n number of times, which purely depends upon the condition. Until unless the condition becomes false, everything, the condition, the body and the update section, they are going to execute for n number of times. But the initialization is going to execute for only one time. This is the important point you should remember here. Now let us write a simple program to display the integer values from 1 to 10 using for loop. We know that the program always starts with the preprocessor directive #include stdio.h, and after that we have this global section, and then I have the main function like this, and then I take a variable I and I am initializing it to 0. And you can observe here that this I can be treated as the counter variable. It counts the number of iterations. That's why we call it as a counter variable. Now let me write the for loop. I want to print the value of I starting from 1, let us say. So let me erase it. Instead of 0, let me put it as 1. So at the declaration part, I know that the memory will be allocated and the initial value 1 is stored inside the memory like this. Let me take the base address as 100. So the for loop for I is equal to, already it is initialized, right? For I is equal to 1. So since the counter variable is already initialized, you can skip this section also. You can omit it. Or else you can do one more thing. You just declare the variable I here, such that initially it will have some garbage value. Once you initialize this I to 1, 1 will be stored here, and I less than or equal to, not equal to, I less than 10, I plus plus, and every time I want to print the value, therefore I will use the printf statement and \n I is equal to 1, I is equal to %d, and this %d is for I. So let us see how it is going to execute. The execution always starts with the main function, and the first statement is the declaration of an integer variable I. So I is declared with some garbage value, and then the second statement is the for loop. As the for loop, you can see here that there exist 3 components. One is the initialization, where I have initialized the value of I to 1, and then I have the condition where I have kept the condition as I less than 10, and then I have the increment part, which is called as the update part, and the body of the for loop consists of only single statement to print the value of I. So it prints I is equal to something like this, right? So let us start our execution. When the compiler comes across this statement for loop, I is initialized to 1, and as I told that the initialization happens only once. Here I is initialized to 1, therefore 1 is stored here, and it will check the condition. The second part it is going to execute is the condition. So 1 less than 10, the condition is true. Once the condition is true, as I told that the body of the for loop will be executed, therefore it will execute the body, this statement, and it will print it as I is equal to, what is the value we have at I? It is 1. And after executing the body of the for loop, you can see that the third component is executed, that is the updation part is executed, this one. I plus plus means it is nothing but I plus 1, therefore the value of I becomes 2. Now 2 less than, again it will come for checking the condition. 2 less than 10, this condition is true, it will execute the body, therefore I is equal to, now the present value of I is 2, it is printed. Again it will increment the value, now it becomes 3. Again it will check the condition, 3 less than 10, condition true, execute the body, I is equal to 3. Now increment the value, it becomes 4, 4 less than 10, condition true, execute the body, I is equal to 4. Now increment, I becomes 5, 5 less than 10, condition true, execute the body, it will print I is equal to 5. Increment, it becomes 6, 6 less than 10, condition true, it will print the value 6. Now increment, I becomes 7, 7 less than 10, condition true, print the value of I. Increment the value of I, it becomes 8, 8 less than 10, condition true, it will print, therefore I is equal to 8. Now increment, I becomes 9, 9 less than 10, condition true, it will print the value of 9. Now at this point I value becomes 10. You can see here that the condition it is going to check is I, that is 10 less than 10, which is condition is false, therefore it will not execute the body and it will simply exit from the body of the for loop, or it will simply exit from the for loop, and there are no statements to execute in the main function, therefore this is the end of the program. So the program what you have written will print the I value starting from starting from 1, and it will print up to 9. If you want to print up to 10, then what you will do is you will simply put here as I less than or equal to 10. So at the last point what happens is that if the condition is checked, 10 less than or equal to 10, condition becomes true, and then I is equal to 10 is printed. Now increment, I becomes 11, 11 less than or equal to 10, condition is false, therefore it will exit from the for loop. This is how the for loop is going to execute. So we have seen the syntax of the for loop, how the for loop is going to execute, and we have already seen one example to get the functionality of the for loop, and the program is to print the numbers from 1 to 10 using repetitive construct, which is the for loop. In the similar lines, let us discuss the other looping construct that is available with C, that is the while loop. We'll start our discussion with the syntax. Syntax is nothing but the rule. So while you are going for any programming language, it is necessary that you always have sound knowledge on the syntaxes that are used in the programming language. Then only you can learn the concepts. Then only you can have sound knowledge in the programming language. Good knowledge in syntax is equal to good knowledge in the programming language. Therefore, let us start our syntax of while loop. The while loop syntax starts with while keyword, and after the while keyword you will have the condition and the statements that constitute the body of the while loop. So this is the very simple syntax that forms the while loop. Very simple thing. It starts with a keyword while, and then it will check for the condition, and then it has the body of the while loop. You can see that the body starts from the here to here, right? So this is the body. Sorry. This is the body of while loop. Right. So let us see how it is going to execute. But before discussing about the execution of the while loop, I told in the previous discussion that any looping construct requires three components. That is the initialization component, second one is the condition component, and the third one is update component. But we have seen all these three components in the for construct or for loop. But what happened to this initialization and update part in the while loop? We have only condition part. What happened to initialization and update? They are also required in the while condition, but we are not going to specify them in the same statement. So the initialization should always happen before the checking of condition. Therefore, you can write the initialization part anywhere before you start the while loop. Before you start the while loop, anywhere you can put the initialization part. So before the while loop, I will put here the initialization part. So initialization happens once, and then it will check for the condition. If the condition is true, it is going to execute the body of the for loop. And what happened to this update part? We don't have the update part in the while construct, right? But that means I am not specifying it in the same statement, but out of these statements which constitute the body of the while loop, at least one statement should be related to the updation part. So within this body, one statement you have to write it as the update construct or update component. So updation of the counter variable happens within the body of the while loop, and the initialization of the counter variable happens before the while construct. These are the two important points you should observe in the while loop. So initialization happens before while, and the updation happens within the body of the while. These 2 points you should keep it in mind, and let us see how it is going to execute, how the while condition is going to execute. So the initialization happens, and then initialization of, we know that what we are going to initialize, we are going to initialize the counter variable. So the counter variable is going to initialize, and then when the compiler comes here, it will check the condition. I have given very important note on the previous discussion that specifying the condition with proper values is very much important. Why? Because if you don't specify the condition properly, you may end up in a situation where your loop is going to repeat unlimitedly. That means it is going to execute the loop infinite number of times, where such situation we call it as the infinity loop. So you are going to enter into the infinity loop. To avoid entering ourselves into the infinity loop, you just need to be very careful in specifying the condition. So specify the condition properly, and then you can get good programs, right? So let us see how this is going to execute. After initialization, you will check the condition. If the condition is true, then the body is executed. Anyhow, if the body is executed, one of the statement in the body is the update. Therefore, updation of the counter variable happens within the body, and then again it will check the condition. If the condition is true, execute the body. When you are executing the body, update automatically takes place. Again, go for checking the condition. If it is true, execute the body, update condition, execute the body, check the condition, execute the body. This particular looping construct happens until the condition becomes false. So if the condition is false, it will simply come out of the while loop or the looping construct, and it will execute the statement 4. So in this particular body of the while loop, it is not mandatory that there should be some limited number of statements. You can have a single statement, or you can have some n number of statements, or you can have some m number of statements. There is no limit out there, right? So this is the point, you should keep it in mind. And let us discuss this while loop with one programming example. We'll take the same example of printing the integer values from 1 to 10. As usually, we'll start our program with the preprocessor directive #include stdio.h, and then I start my main program. I declare my counter variable I, and before starting the while, we know that we need to initialize the counter variable. So let me initialize the counter variable with I is equal to 1, and then I write my while construct while the same conditions. So in the previous example, we have seen the for loop as for I is equal to 1, I less than or equal to 10, I plus plus. So the same condition happens here with the same statements. I is equal to 1, that is the initialization has done here before the while construct, and we will put the same condition I less than or equal to 10, okay, and then I will print the I value, printf \n I is equal to %d comma I. And remember that you have to update, or you have to place one particular statement which is related to updation of the counter variable within the body of the while loop. So this particular part you will place it here, and the condition you place it in the condition here, and initialization we know that it is done before the while loop like this. So I put this I plus plus, and then I close my while loop and I close my main. So this is a very simple program which simulates or which illustrates the working of the while loop. Let us start the execution first. So any program will start its execution from the main, and this is the initialization part. Therefore memory will be allocated. Let me take the base address as 200, and initially garbage value will be there. And in the second statement, it is going to initialize the value of I to 1 like this. And then the third statement is this one, while I less than or equal to 10, that means 1 less than or equal to 10, condition becomes true. When the condition is true, it is going to execute the body. Here you can observe that the body consists of two statements. One is the printf statement, and the second one is updation of the counter value, right? So printf I is equal to percentile d. I am writing the output here. Output is I is equal to 1 is printed. Now I am incrementing the value of I. So I becomes 2. Again it will check the condition, 2 less than or equal to 10, condition true. Again print the value of I. Now I is incremented with I plus plus, so it becomes 3. Again check the condition, 3 less than or equal to 10, condition true. Execute the body, I is printed and I is incremented. Again check the condition, 4 less than or equal to 10, yes, condition true. Therefore execute the body, therefore I is printed and then I is incremented. Now check the condition, 5 less than or equal to 10, condition true. Execute the body, so I is printed and I is incremented. Now 6 less than 10, condition true. Print the I value, increment the I value. Check the condition, 7 less than 10, true. Therefore execute the body, print the I value, increment it. Again check the condition, 8 less than 10, true. I is printed and then I is incremented. Now 9, check the condition, 9 less than 10, condition true. Print the I value, increment it. Now 10 less than or equal to 10, condition true. Therefore execute the body, I is equal to 10 is executed and I plus plus means I value becomes 11. At this point 11 less than or equal to 10, this condition becomes false. Whenever the condition is false, the body or the control will come out of the looping construct. So when it come out of the looping construct, there are no statements here to execute in the main function. Therefore this is the end of the main program. So the output what we get is the value of I starting from I1 and ending with 10. So the same construct or the same program, we have rewritten the same program with the while loop, but you should be very careful where we put this initialization. Where we put this condition and where we put this updation part. Remember that the initialization is always placed before the while construct and the condition is placed within the parenthesis of the while construct, and the updation part is kept inside the body of the while loop. So these important points you should keep it in mind, and let us move our discussion to the last programming or the looping construct we have, that is do while. The syntax of the do while is, it starts with the keyword do and then the body of the do while loop, and we will end this do while loop with while followed by condition. Remember, very important point regarding this do while is, we should always end the do while construct with a semicolon, that is the statement terminator. This is not required, the semicolon is not required for the for loop as well as the while loop, but do while loop always requires this statement terminator. Very important point, right? So it always starts with do and then we have the body of the do while, and we will specify the condition at the end part. We will specify the condition at the end part. The same point where we have to put the initialization, where we have to put the condition, and where we put the updation part. We know the condition is kept here, right, after this while, and similar to that of the while construct, the initialization is above the do while construct. Anywhere we can put there. and the updation part is within the body of the do while. So out of these n number of statements, one statement should be updation part. One statement is update. So the same thing happens in the while as well as do while also. Initialization is before the construct and updation is within the body of the construct, and the condition is specified in the while. And let us explain this with the same program of printing n number of values, that means 10 values, 10 integer values. This is my preprocessor directive, and this is the main function. I take a counter variable int I, and as we need to initialize, I am initializing this counter variable I is equal to 1, and I start my do. Since the my part is to print the value of I write the printf statement \n I is equal to %d I, and don't forget about this update statement. I need to update it I ++, and then you have to write the condition with while I less than or equal to 10, and don't forget this semicolon. That is the end of this one. Let us see how it is going to execute. Execution part. Execution always starts with main, and when it enters into the body of the main, the first one is the declaration part. Therefore I is initialized, or I is allocated some memory. Let us assume that the base address is 300, and initially it stores the garbage value, and at this point, since it is initialization, the garbage value is overwritten with the value of 1, and then we have this do while do, and whenever it is executing this do, it has nothing to do except to enter into the body of the do while. So for the first time, it is not going to check the condition. For the first time, no condition is checked. Its task is simply to go for the execute this do and enter into the do while loop without any checking the condition, right? So printf, so the body is executed, printf, I am writing the output here, I is equal to 1 is printed, and now I value becomes 2. It becomes 2, and it will again check the condition while 2 less than or equal to 10, condition true. Therefore it will again execute the do while loop. It will again execute the body of the do while loop. So I is printed, increment the value of I, okay, and while 3 less than or equal to 10, condition true. Therefore execute the body of the loop. Now I have the value of 3, increment the value of I, which becomes 4, again check the condition 4 less than or equal to 10, condition true, execute the body, I value 4 is printed, increment the value of I value becomes 5, and then it will print the value of I, increment the value of I becomes 6, 6 less than 10, true, execute the body, I is equal to 6 is printed, and then I is incremented, 7 less than or equal to 10, condition true, execute the body, while executing I value is printed, and then I value is incremented. Again check the condition, 8 less than or equal to 10, condition true, execute the body, so I value is printed and it is incremented. Again check the condition, 9 less than 10, condition true, execute the body, I is equal to 9 is printed, I ++, 10, so I becomes 10, 10 less than or equal to 10, condition true, therefore execute the body, so I is equal to 10 is printed. Now I value is incremented, which becomes 11, 11 check the condition, 11 less than 10, condition false, therefore it will exit from the do while, and since there are no statements in the main, it will end the execution of the main program also, right? So one important point you should observe here is the condition which we are going to check in the do while is checked while you are exiting from the do while you are coming out of the do while. Therefore, this is the reason why we call this do while as the exit controlled loop. Exit controlled loop, right? And if you observe the remaining two things, that is the for loop see here, the for loop you are going to check the condition before entering into the loop. Similarly, while loop, you are going to, while loop also you are going to check the condition before entering into the loop. So in order to enter the loop of for and while, you have to initially check the condition, and if it is true, then only you are going to enter into the body of those loops. But this is the do while is something different, where you are not initially checking. That means first time execution is done without checking the condition. This is very important. And the condition what you are going to check is going to be checked at the exit part. While you are leaving the body of the for do while loop, you are going to check the condition. That is the reason we categorize the for loop and while loop under the category of entry control loop. That means simple thing, entry control loop means it is going to check the condition while you are entering, while you are taking an entry into the body of the construct. And exit control loop, the do while is categorized under the exit control loop. That means you are going to check the condition while you are exiting from the body of the do while loop. So keeping these two in mind, we have completely discussed what do you mean by the repetition, what are the various terminologies we have under this repetition, like the iteration or looping. Any term you can use, but most preferably we can make use of the term iterations. So when you hear the term iterations, it is nothing but repetitions, or you can also make use of the loops. And we have already seen why we require these looping constructs in C. The primary advantage why we require these loops means in order to repeat a set of statements, a single statement or a set of statements, we make use of these looping constructs. So what is the advantage we get from these looping construct means the effort of the programmer to repeat some set of statements will be reduced. At the same time, you can have a smaller code. The size of the code is also reduced. So these are the various advantages we have. One is the size of the code is reduced. Why? Because you are going to repeat the same set of statements. You are not rewriting those statements. So the program length is reduced, the program size is reduced, as well as you can also have the benefit of faster execution speeds or execution times. And after that, we have seen what are the various constructs that are available in the C programming language, looping constructs, that is the for loop, while loop and do while loop. And then we have seen each and everything, the for loop, while loop and do while loop. We have explained everything with respect to their syntax and with respect to a programming example also. We have clearly explained why the for and while are called as the entry control loops and why this do while is called as the exit control loop. Once we are done with this particular explanation part, let us finally discuss one very important point, that is while versus do while. What are the differences between the while and do while? So let me take the left part as while and the right part as do while. By listening to the previous discussions, you can simply identify the first difference. While is the entry control loop, whereas the do while is the exit control loop. Second one, you can write the syntax as one of the difference between the while and do while. The syntax of while is while and it is condition, and then we have the statements like this. Whereas the do while will start with the keyword do and we have the statements, and it will end with the while along with condition like this. And the third important point, the third important difference between the while and do while, you can let me write one particular thing. While, let me take this syntax, right? So if the condition is false for the first time itself, we are not going to execute the body of the while loop. So the minimum number of times the while loop, the while loop is executed is 0. So minimum, let me write clearly, minimum iterations that happens in while loop will be 0. So when is this 0 going to happen means, we know that whenever the condition is false for the first time itself, then it is not going to enter into the body of the while loop. It will simply exit from the while loop. So it is not going to execute the body. Not even a single iteration is going to happen. Therefore, the minimum iterations that happens in the while loop is 0. But let us take the same thing. How many minimum iterations it can happen in the do while? So if you observe this do while construct, since it is an exit control loop, when the compiler comes across this do statement, it will simply execute the body. Even though the condition is false for the first time itself, it is going to execute the body of the do while loop at least once. So the minimum iterations that happen in the do while is at least once. Even though the condition is false for the first time itself, it doesn't matter. It will first execute the body and then it will going to check the condition, since it is a exit controlled loop. So for this purpose, what happens here is the condition, the body of the do while is going to execute for at least once. Therefore, the minimum iterations that happen with the do while loop is at least once. So these are the various differences, very important. You should be very careful and you should be very attentive while answering this question, that is while versus do while, very important thing. And let us end up our topic with a small discussion. So we have three different constructs. I have a question here. We have three different constructs. One is the for, second one is while, and the third one is do while. Out of these three constructs, as an initial programmer, everybody will be having this doubt. Out of these three constructs, which construct we have to use? Whether it is better to use the for construct or while construct or do while construct? The answer to this particular question is there is no particular thumb rule saying that one particular looping construct is better than the other looping construct, right? So everything is similar. You can convert the programs written with for loop, written using for loop, into the programs with while loop, and similarly you can convert the for loop to do while. You can convert the while to for, while to do while to for, do while to while. Any conversion is possible. Therefore, it doesn't matter which construct you are going to use. But After discussing about these differences, you can see here that do while you are going to use it whenever you want to execute the body of the loop at least once. So if there is a situation that arises that you want to execute the body of the do while at least once, in such situations you go for do while loop. In other programs you can convert this for to while, for to do while, and while to for, while to do while, like that it can happen, right? But when there is a situation you always require to execute the body at least once, you always prefer do while. But still there is another, I told that the answer for this which construct is better means everything is similar. You can use any construct for designing or implementing your programs. But most of the programmers, they feel more comfortable with the for loop instead of while and do while. The reason for this thing, while the programmers prefer to use the for loop, is by looking at the syntax you can see that the for loop, all the looping constructs involves three different components, right? One is the initialization, and then we have the condition, and then we have the update part. So all the constructs, all the looping constructs, they require the initialization, condition and update. All these three components are mandatory. But you can observe in the for loop construct that all the three components, initialization, condition, updation, are written in the single line itself. One single statement is enough to specify these three things. So for this purpose, if there are any particular bug issues that arise, in such situations you can debug the for loop very easily. Why? Because the initialization happens and the condition and update, everything happens in a single statement. So you can directly go to this particular statement and you can check these three components at a single stretch. For this purpose, the for loop is more convenient than the other two looping constructs. The reason is, all the three components, the initialization, condition and updation parts, are placed in a single statement, which makes the programmer to debug the programs very easily if there is a situation where the bug is arising. So for this purpose, programmers prefer the for loop. So these are the two important points that we have discussed in the last as the last topic, that is while versus do while, very important thing. And the question format I have given is which one to prefer, for while or do while. Do while is always preferred whenever you want to execute the body at least once. For is always preferred. Why? Because everything is placed in a single statement, therefore debugging becomes easy in such situations. So that's all for today's session. We have completed the topic on the looping constructs that are available in C. Thank you one and all for joining the session.